All right, guys, we have a quadratic over a linear, so it's important for us to see the structure here. When the coefficient's negative, it's going to look like this. We're going to have a, to the right, we're going to have a maximum, and then to the left, we're going to have a minimum, as we can see. And if the coefficient's positive, it's going to be the other way around. We're going to have a minimum to the right and a maximum to the left. So we obviously have this case right here, and the other cases where the factors cancel and we have a line with the hole in there. So this is easy enough where we could just literally use a slider to figure, until it gets to negative 16. But it's a cool method we can use called the derivative method. So watch this. I put f of x1. I want that to equal negative 16, but the derivative there is 0. So look at that. So I'm done. P is 5. Okay, it's pretty cool, right? P equals 5. So there's 3 types, right? There you go. Okay, we have this problem here. So I'm going to first type that equation in. 3x squared plus 18x plus 3y squared minus 6y, excuse me, minus k equals 0. What is k? K is the sum of the solutions, so opposite b over a, so that's 9. Okay, so I'm just going to make it a 9. You got to be able to get that. All right, easy. So it's going to be 4.60555 minus that. So 4.60555 plus, that's my diameter, right? That's my diameter. That's my radius. So what happens when I square it? So my radius squared, I can tell, is 13, okay? So my radius squared is 13, okay? So like I said, my radius squared is 13. We have a circle inscribed in a square, right? Circle inside of the square. So I know that the circle area, pi r squared, right? So r squared is 13. So it's just going to be 13 pi is the area of the circle, right? Now, r squared equals the area of the square, 1/4, right? So I'm going to do 4 of them, so 52. Okay, so it's 52 minus 13 pi, so 11.1519, so 11.2. Okay. Okay, good. All right, we just got to set this up carefully, guys. We have a concentration of a chemical compound is equal to the amount of a substance in the container in moles. So let's do that, guys. Let's do concentration is equal to the moles divided by the volume, right? And since we have 2 spheres, I'm going to put 4/3 pi, and it tells me the radius of the larger, so I'm going to put the 4r there, right? 4r cubed. Great. And just fill in the stuff. Each sphere has, so m equals 144. Okay. Radius of the large sphere is this. Concentration of the compound in the larger container is 3 moles, so I'm going to say C equals 3. Okay, cool. So then it wants me to find the positive difference between the volumes. So watch this, guys. Let Desmos do what it does. So pi, I'm going to do 4r cubed minus 4/3, right? Just do this, pi r cubed, okay? So 47.25. Good problem, okay? So you can do it efficiently on Desmos. Don't be intimidated by the words, just break it down. The wordier the problem, the easier the math. It's just a 3-variable equation. So, okay. All right, guys. So we have this problem. 2 ways to do it. We say that h is equal to the product of the roots. So h has to be 3, right? C over a. So there's 2 ways to do it. One way is really not better than the other. So it depends on what you like. So I'm going to show you the first way to do it. It's an equivalent expression, guys. So whenever that happens, it's true for all values of x. So we want to indicate that. So the first way to do it is this. Excuse me. So true for all values of x. Okay, so P is going to be that. So 22 would be my answer. Okay. So that's one way to do it. The other way to do it is to create functions. So some people like doing it this way. It's not, like I said, it's just preference. You know, one way is really not better than the other. It's just what you like doing. For this problem, I'd probably do the first way, but you know, this way is not bad. So then we do this way. We regress it. We still have to put some values in. So all right. So same result. Okay. So the first way is less typing, I guess. But so for equivalent expressions, true for all values of x, you want to consider these two approaches. Okay. It's easy. So choice B. All right, guys. I want to show you the derivative method here. So whenever you have a quadratic linear system and we want one solution, please consider the derivative method. Really easy. So I do that, and then my g of x is going to get that in the linear form, equals 40x minus a over 4, right? So put that. Now, I'm not going to add the slider. I'm going to say h of x equals f of x minus g of x. And let's do the derivative method, right? So I want the 0 of h, and the derivative at that point is 0. So h of x1 is 0. H prime of x1 is 0. So a is 123. I'm done. Okay. Cool. All right, this one's easy, guys. Just use the function list method. F of x equals mx plus b. So I'm just going to do this. Function of -7. Function of -4. Function of 1 minus 3d. And I'm going to put one more function of -4 to make it 0 because it's the x-intercept. So let's do that. So just do that, guys, and it's easy, okay? So I do that, and then I say dk. So -169 over 6, okay? Good. All right, so the sum of, in triangle inequality theorem, the sum of any two sides are greater than the remaining side, right? It's like the shortest distance between two lines, 2 points is a straight line. It's just common sense as well. So to find the limits, I'm going to, who cares about doing inequalities? I'm just going to do it this way. This plus this, right? Has to be greater than that. So let's find out what the limit is. So 39 has to be one of the limits, okay? So 39 is one of the limits. Let's do the other ones now. So I'm going to say 4x1 plus 20 plus 7x1 minus 11 tilde 2x1 plus 8. So nonsense because it's negative. Just ignore that. So what did I do? I did this and this. So now I have to do the other one. So 2, the only remaining one is this, 2x1 plus 8 plus 7x1 minus 11 tilde 4x1 plus 20. So the other limit is 4.6, so it has to be choice D because when we divide by 5, we get that, right? 23 over 5 is 4.6, and then 195 over 5 is 39, okay? Guys, these are so easy, so, you don't shouldn't struggle with these problems. So notice the structure. It says equivalent expression, equivalent form. So they're all the same when we graph them, so I might as well just graph one of them. And then it says when each time x increases by a fourth. So just do it like this, guys. F of a fourth divided by f of 0. So I want to see a 10, so it has to be choice C, okay? Easy. Now the other one's kind of going backwards. For number 9, we see that ignore choice D. Same thing. They're all equivalent, so I do this. You only have to plot one of them. This time it says, what do I have to go up by, right? What do I have to go up by in order to get a factor of 27? So this one I would just do this. Okay, so where do we see a 6? Choice B, we're done. And you should also understand the interpretation, guys. This is a classical exponential. Every time the growth factor is 27, x increases by 6. So it has that form, right? So classical exponential form. All right, easy, D. So f of x equals ax squared plus bx plus c minus. Okay, so we're going to get our A because we have the symmetry here. So function of -9 equals function of -2. Okay. Yeah, so A has to be negative. Like I said, that part's stuck. And then so does A have to be less than -3/4? No, it doesn't. So we eliminate that. Does K have to be more than 16? Um, so we see that it does, guys, because C has to be more than 0, right? So like C has to be, it can be this at a limit. And even then, I get a 19.25, right? So the greater we make C, higher we go. So it does have to be that. So 2 only, choice B, okay?